Hi everybody, we're delighted to be here today to talk about the application of AI and data analytics. From road safety, crowd monitoring at airports, through to reducing 4 days of work into 4 minutes, we're going to talk you through real-life applications of AI and data analytics that are being used today. My name's Jennifer Liu and I work for InvestNI, the economic development agency for Northern Ireland. Today, we're lucky enough to hear from 3 innovative Northern Irish companies about how their customers, major public and private sector organisations, are utilising AI and data analytics to enable them to do things faster, more easily, or simply do things that they just could not do before. So, introducing our panellists, we've got Philip McAleese, co-founder and CEO of C-Sense, the intelligent bike light with RoadSense. Stuart Mills, COO of CrowdVision, automated people tracking using video analytics. And Dr. Alistair McKinley, CTO of Analytics Engines, the data analytics solution providers. And without further ado, let's hand over to our first panelist and case study. Over to you, Philip, from C-Sense.
Thank you, Jenny. So the big question that I'm going to answer for you today is, why does a bike light need artificial intelligence? And I'll do that by taking you through my journey and where it started and where we ended up, how we ended up with the opportunity to use AI. So the average cyclist actually commutes to work in an environment like this. And I was in client-facing technology based in Asia, and I have a very similar story where I was a busy executive and didn't have much time to go to the gym. So I took up cycling as a way of getting a bit of exercise into my daily routine. Fed up with daily misses on the roads, I wanted something to improve my visibility, to help me stand out and give me better safety. So I looked at the accident stats online and saw that more than 2/3 of all cycling accidents occur at or near road junctions in urban areas and during daylight hours. And I also realized that a lot of the cars were getting daylight visible running lights, and that's because of European legislation since 2011, because it reduces vehicle-to-vehicle collisions by around 5 to 10%. And so I figured if something as big as a car needs it, then me and a bicycle, I'd absolutely like that as well. So I started out with very bright lights, which were bright enough to be visible in the daytime. They were actually mountain bike style lights. And they worked really well. They gave me the presence on the road. They gave me a better experience and a much safer journey. But the downsides were they were big and bulky and they're expensive. So you don't want to leave them on the bike because they can be stolen. And you don't want to take them with you because you get these big battery packs and wires and it's just not convenient. And so I was cycling along one day looking at the smartphone on my handlebars, and I realized that it had a level of situational awareness. It knew from its sensor systems where I was going, a little bit about the environment around me. And so I thought, what if we took the smart sensor technology from the mobile phone and we integrated it into the backlight to give it the situational awareness? Then it can flash brighter and faster in situations when I need to be seen most, such as roundabouts, road junctions, filtering in traffic, and so on. And it can conserve energy and flash more conservatively, and I guess a little bit less bright whenever I'm not in one of those situations. By doing that, we can reduce the average energy consumption, make it still daylight visible, but make it a much smaller, more convenient device. And so I relocated from Asia back to Northern Ireland, where I'm originally from, set up the company, and we began to develop this idea. So one of the challenges that we faced, we imagined to begin with that we would use a lot of algorithms to work out when you were at a road junction, a roundabout, and so on. But what we realized is that there were just quite a lot of variables. Just thinking about bicycles, not only have you got all these different styles of bicycles, but you've got different tire widths, tire pressures, frame materials, and so on. And each of those requires different calibration for the device in order to make sure that it reacts well, but not too much and not too little. And much more than that, we realized there were so many other things that we had to layer on, understanding the rider's experience and how they were reacting to the environment, understanding what the road surface was like and how that factors into the experience, and even looking at things like light levels to understand were we cycling in the daytime or the evening, and of course what the surrounding traffic was doing as well. So we realized that in order to crack all of this, it wasn't going to be a basic algorithm. It would have to be AI, and we would have to run the AI on the device itself. And that's precisely what we did. So we used a neural network running bare metal on the edge on the device to give it never before seen processing capabilities. And that allows us to profile a number of things. So first and foremost, we profile the cyclist, understanding their level of experience. And that's purely because if you're an experienced cyclist, you'll typically look much further ahead, anticipate further, and so you'll give less clues in terms of your input, your braking and steering and so on to the light to allow it to react to those situations. And on the flip side, if you're a relatively new beginner cyclist, you're going to be relatively abrupt with your inputs. And again, the light could be overreacting. So we profile that to make sure that we get it right. And so that allows us to do some really, really clever things. We discovered through testing that in 83% of cases, we can identify when a car is approaching from behind. Now, we don't have any direct sensors that can measure that car's approach. What we're actually measuring is the reaction of the cyclist. So the AI, when it's sufficiently tuned in, will identify that you as a cyclist are subconsciously slowing down to allow the car to pass, or subconsciously going a little bit faster in order to try and sort of outrun the car, or to reduce the relative speed of overtake as that car passes you. We realized as well through testing that as we were working through with a lot of this data, there was a massive amount of it that had practical applications for use in better design and planning of our city's infrastructure. And so we opened it up to the crowd and we said, if you'd like to opt in to help your city, we can aggregate all of those useful insights and data and telemetry that we're gathering from all the bikes to give never before seen insights. And so this is a lot more than just where people go. This is understanding about how they go there, what their experience is like, where they're having issues. And it really does show up that things like the pros and cons of infrastructure and does it really work? You know, so we did a project where we looked at some of the bridges across the rivers in London, and we saw that there was actually, you know, a better cycling experience on bridges which had dedicated cycle lanes, which of course is no surprise. But what we did find, which was perhaps quite surprising, was that where you had a defined cycle lane and the cyclists were constrained within it, when you had a set of traffic lights at the end of that, you would get congestion and bunching of cyclists. So on a normal road, they can move out and expand and use the full width of the road, the advanced stop line, and you'll get a lot of cyclists through on each change of the traffic lights. But where they're constrained to a cycle lane, they're perhaps only 2 or 3 abreast, and so much fewer number of cyclists can get through at each change of the traffic lights. In Dublin, we saw a really interesting piece of infrastructure. So there's a lovely road with you know, cycle lanes and nice centralized segregated lane down the middle, so there's no cars crossing left and right. It looked absolutely perfect from a design perspective, and everything indicated that it should be a wonderful piece of infrastructure. But what we saw was that there was actually quite a lot of interactions between the cyclists and the pedestrians. There were restricted sight lines around St. Stephen's Green as people came out from between quite thick hedges onto the road, and they would often step onto the road, perhaps not hearing the cyclist coming because they were on their phone or otherwise distracted, which was a really useful insight on infrastructure that should have been really good. And then we've also seen most recently in Oxfordshire, where they've looked and profiled pre and post-COVID cycling to understand what's happening. And things like cycle counters will obviously identify changes in numbers of cyclists, but what we were able to identify was that there was actually a change in the types of cyclists based on their experience levels and also the types of journeys that they were undertaking. And of course, it doesn't stop there, because most cycle tools, and indeed a lot of what we've done to date, has focused on trends from historical data. Indeed, the most used tool in the United Kingdom relies on census data, which is now nearly a decade old. So we're using AI in a second layer to take this to a whole new level. We're using intelligent actors, which are trained to behave differently. So all of that really interesting telemetry data, we're using it to create commuter cyclists, enthusiasts, leisure cyclists, food delivery cyclists, cargo bikes, and more. And then what we're able to do is put in things like roadworks, new cycling infrastructure, and we can see how those actors interact with that infrastructure to allow planning at a level that has never been seen before for cycling. Thank you.
That was great. Thank you so much, Philip. Now let's move on to Stuart from CrowdVision.
Thanks, Jenny, and hello to everyone. Well, to introduce myself, first of all, I am Stuart Mills from CrowdVision. We are an AI-empowered company. We've been actively using AI as part of our solution for 11 years. And I want to tell you just a little bit about how we do that, and then talk about some of our customers and some of the solutions where data is being accessed from the system and put to real operational use. So firstly, as we go through, I've said for more than 10 years we've been using AI, and for us it's important that this is a real tool and not just a buzzword. I think a lot of people are familiar with the term but don't really understand it, and generally I think that's fine. I think really what a lot of users are looking for is what comes out as a result of the effective use of AI. And in this case, for CrowdVision, this is all about a variety of data that's actually critical in an operational environment. And earlier on, you heard Jenny mention our close involvement with airlines and airports, which is very true. But that also extends for us to other busy places, large-scale stadiums or expo centers, other transportation hubs, large-scale casinos and resorts. So this is for us very much around, as our company name would suggest, the data and the dynamics of crowds and how to effectively manage those. And certainly in our early days, we were very focused on public safety and public health, and then expanded out really to sort of customer satisfaction. And now with COVID coming back in to affect our world, now it's about a combination of these things. So our history very much plays a part in our current day-to-day activities. And as I said, the technology is underpinned with AI and with machine learning. And you'll see a little bit of this as I go through the next slides. So I've used this example of an airport. We work with a lot of airports around the world, but equally this could be any number of large-scale venues. So we are a sensor agnostic technology. So whether your sensor is something like a camera mounted in the roof, whether it's a LiDAR device, whether it's a Wi-Fi device, we genuinely don't care. What we care is the output from that device to put through our AI engine, and so that our software starts to use machine learning to understand more and more about the space. And that's important because as we actually move through this cycle, and you can see in this example here, we're not doing this on a single camera, for example. We're taking multiple cameras and creating a stitch to give you an overview of an entire space so you understand what's happening in the space. And then you can highlight particular zones to make sure you're really focusing in on those areas of interest, with the end goal of generating high quality, highly accurate data that can actually be used in your operations, either on a live basis or by looking at trend and historical data, so you can apply learnings to your operations moving forward. And the final point on this is the sort of consumption of this data for the end users. I mean, most of our end users, vary in their understanding and knowledge of how everything works, under the covers. But what they do know very well is the data they want and how they want to consume it. And you'll see as I go through some more of these slides, how this is being used in a real world environment. So this really gives you a sort of pictorial view of what I was just saying. Inputs are coming either from live IP cameras mounted up on the roof or from LiDAR sensors or Wi-Fi. And then we have detection and perception engines, depending where we're getting the data from, that interpret and understand. And this is really where AI and the machine learning concepts are really doing all the hard work. And if you take a simple scenario of a check-in line at an airport, you have a situation here where an overhead camera, for example, is seeing this space, but then has to understand that it's people in the space and how the people are moving and how long they're queuing for, and in the modern world, whether they're socially separated at an appropriate level. So it's doing all this sort of clever stuff and putting it into what we call a detection database. And from there, we then have a second part of the solution that's aggregating this data to create key metrics. And those are things that stakeholders across the business, whether they're safety, security, customer service, commercial, are looking at all the time. So I hope this gives a clear image of the flow of the software. We've already talked about the way in which the data can be consumed, but I'll be coming back to some examples from customers so you can see how this is really happening. So I've got some examples here. These are from different airports around the world, and it's really to show you some of the things that we're doing using the AI and the machine learning. Whether it be on the left-hand side, where from a camera view, and you can see the sort of blue outline where we've marked this as a zone of interest, whereas people flow in and out of this space, we're detecting who the people are in the space, not their actual name and address, but just that they are real people. And it doesn't matter whether they are 7 foot tall or 2 foot tall or in a wheelchair. We're making sure that we're understanding that this is someone going through the space with a head and shoulders, basically. And you can see also on this image, we're also tracking the direction they're heading and the speed they're heading. We're not trying to track them over a long space. What we're trying to do is just get an idea of flows through the space and number of people in this space. The middle example here is sort of spatial utilization. And this is less about the number of people and the time they're taking, and more about how effectively is the space being used. And if you're looking at the image trying to figure it out, this is a divestment area in an airport where you put your bags onto the table there and they move down to the X-ray machine. But what we care about in this example is how the floor space is effectively being used and how passengers are moving in and out of it and how long they're taking. And then on the third example, we've got some basic business rules that are picking up here in terms of coverage for a space. On the left-hand side, you can see the system is understanding how many people are in the queuing area, how long the queuing time is taking, how long people are being processed down the right-hand side at a check-in desk, whether there are check-in desks available with a staff member that are not yet serving a customer. So there's quite a lot of data being pulled from this last example here. And then that data is also overlaid, as I mentioned, with the social separation analytics. Are you staying 2 meters apart? If you're not, is your exposure time to the person next to you more than 2 minutes? And those are kind of typical parameters, but equally those are things that each location could change depending on local legislation or local recommendation as to what that distance should be and what that time should be. And that then enables us to give a safety rating to the specific areas. And you can see down at the bottom here, I've highlighted some of the AI techniques that we've utilized in delivering this functionality. And to be clear, our customers wouldn't see these views. I'm sharing these views with you so you understand what's going on, but actually these views get turned into data, and the data is then consumed either through our live dashboards or our reporting system or through our API. So this is really education rather than what a customer would see day to day. but it does highlight some of the AI techniques that we're using within the product to actually get this high quality, robust data. So I know we're limited on time here, Jenny, before you push me forwards, but if anyone's got questions on any of these, then please do let me know. Happy to answer any questions. And both of our founders of the business are still with us, working actively in the business day to day. So one of whom is a doctor at Bristol University who specializes in crowd movement and AI. So again, no question too difficult. So just moving forward, I'm showing you some real life examples now from customers around the globe. This is really to give you an idea. You've seen how the data gets generated and the AI and the machine learning working very hard. And this is how it's then represented on a live dashboard in a customer environment. And we use a lot of techniques here to understand what's going on in the space, how long people are waiting, which desks are open, if queues are spontaneously forming, then tracking that sort of dynamic queue experience. So this is all fed into these live dashboards, which our customers use day in, day out in their operational centers. In the second example that I've got here, you know, again, the same sort of dashboard, you'll notice the difference between the first two, and that's because we very much let customers have an input into how this dashboard looks for them. So they often want it to represent the space very precisely, you know, be an effective tool for everyone working within their environment. And you can see here, we're giving them a lot of live up to the second data on the left-hand side related to security, on the right-hand side related to commercial and food and beverage. And this gives them real power in not only operating the airport efficiently and safely, but also still giving customers a great experience, but also making sure customers and staff members are kept safe. So there's quite a lot resting on the shoulders of this solution as it's deployed in airports. And then in this example, as you can see, stakeholder involvement is often very key. So we're sharing this data through a reporting module, and we're aggregating it in different ways depending the view that people would want to see. And then in terms of consumption, my final point here is really the ability to combine different technologies. And you can see in this example, we've integrated our data with other airport systems. So, you know, how great is this? You arrive at JFK Airport in New York, you've got details of your flight, and we're also then pulling the data generated by CrowdVision and telling you which one of the security areas is going to be your fastest route through to your gate. And again, I've been talking a lot about airports, but we do the same things for places like casinos or stadiums or large expos, where a lot of the dynamics are very similar. We want to give a great customer experience. We want to keep customers and staff safe. We want to make sure that data is available quickly so it's actionable, but also on a trend or a historic pattern so that you can look back at how to drive efficiencies in the space. And then I've spoken a little bit about this sort of social separation and exposure analytics, and we think these are quite key. They've been part of our product for a very long time. And of course, the COVID situation has brought them back to the forefront. But again, the ability to get alerts, send those to staff members if there are certain problem zones in the airport, the insight to maybe changing how the layout of check-in areas or security areas or baggage areas can impact safety ratings. And again, getting live information onto the dashboard or through this sort of KPI digest, which really starts to understand based on trends if there are areas that are frequently experiencing issues. So I think this is a good summary to kind of wrap this up. We have used AI since day one and machine learning since day one. We continue to have them at the core of the product, but we're also very conscious that to make them really actionable and business effective, we've got to actually use those techniques and those technologies to give our customers valuable insights into what's happening in their spaces so they can understand what to do. So, Jenny, I'm going to hand back to you. Thank you very much, everyone, for listening, and I hope you enjoy the rest of this webinar.
So many use cases and good timekeeping, Stuart. Thank you very much. Now over to our final panelist, Alistair from Analytics Engines.
Thank you very much, Jennifer. My name is Alistair McKinley. I'm the CTO of Analytics Engines. We're a data analytics and AI solution provider based in Belfast. We work in the fields of AI-based NLP, image processing, and knowledge graph analytics. Today, I'm going to talk about how we built a data analytics solution for Innovate UK to enable new insights and then increase the quality and the efficiency of their response to funding calls. So Innovate UK are the UK's innovation agency. Their remit is to stimulate the UK economy by driving innovation. And they have some pretty impressive statistics about that. They have, since 2007, invested 2.2 billion in supporting innovation in UK businesses. They funded 11,000 projects, are estimated to have created around 70,000 jobs, and delivered around 16 billion in total value to the economy. Very recently, they have been involved in the response to COVID-19, launching a large funding competition to support innovation to assist the response to the pandemic. So the challenge for us in building a solution for Innovate UK was that Innovate UK have an increasing number of competitions of an increasing size. So that's a massive increase in the volume of applications that they are receiving for funding. And they have to efficiently assign assessors to those applications so that they can be properly judged. And that increasing, with that increasing volume, they also have to protect against the potential risk of fraud. According to our project liaison in Innovate UK, they expect the volume and the frequency of applications to continue increasing over time. So these are the challenges that we faced when building the solution for Innovate UK, which was called Cobalt Grant Manager. So it's a data solution that utilizes text analytics to automate the process of assessor matching and grant application checking. So those two processes are: how do we assign assessors from a pool to actually assess the applications for their quality and eligibility, and also the second important part of this is how do we check the text in the documents for potentially fraudulent activity, potentially just resubmissions, enforcing the rules around how many times that companies are allowed to resubmit their applications. So as the volume of applications has increased, this has become an intractable problem for humans to actually tackle, and a data-centric digital approach is required. So as I mentioned, the process automation is key to this. It's using natural language processing to take the parts of structured and unstructured data that we have around assessors. We can also scalably achieve processes in their application pipeline that weren't possible manually. For example, being able to compare a single document against every other application that has already been submitted to Innovate UK in the past, and actually be able to create a similarity score and show that to the people checking the eligibility of each application. So these are the key elements of the solution. Excuse me. Sorry about that. So the impact of the solution really twofold. There are two key processes. One is to assign assessors to applications. Our data solution using the unstructured and structured data that we had about the application assessor pool allowed us to achieve a 97% accuracy with assessing or matching assessors to applications. That's actually a lower rejection rate than they were originally getting through the manual process. So the machine-enabled process was achieving better accuracy than the human process in this case. And crucially, it reduced the time of this process down to minutes. So it's a button click exercise as opposed to several days of multiple people churning through applications and churning through assessor pools to determine what's the right allocation of assessors to those applications. One of the other key impacts was enabling this full document similarity checking, which is an interactable process, meaning that it's not achievable by manual means. Enabling that allows us to check the resubmission status, and it allows Innovate UK to potentially find those areas where multiple resubmissions may be happening, or there might be some fraudulent activity. So a note on scalability, which is a key part of this document similarity checking process. And I just want to explain a little bit about that, why that's not really possible manually. If you have 100,000 documents historically that have been submitted to Innovate UK, what we actually want to do is check each of those against all previous submissions. With approximately 200 sentences per document, this ends up at around 2 trillion sentence comparisons to actually be able to come up with a similarity score for each of those submissions against each other. This is not something that is achievable with a manual process, and is actually something that's even tricky to achieve with a digital process. So you have to be careful about how you implement that analytics process to enable that scalability. But now that it has been implemented as part of Cobalt Grant Manager, they have this unprecedented insight into how documents are being and applications are being resubmitted over time. So, oh, excuse me, there's just a little bit of a delay there, changing slides. So this is actually a screenshot using some dummy data from a test system, actually using some of our own applications, just to highlight the output of what this looks like to a user when they're actually assessing the eligibility of a particular application. Because the search has already been completed against the whole space of previous documents, they can quickly see, what are the similarities between a previous document? Was it submitted by the same people? Was it previously accepted, or was it previously funded? Is it a fault? And make determinations like, is this a valid resubmission? Is it a follow-on project? Or is this just a new application that has some similar text? And that once the large-scale document similarity checking and that analytics process has taken place, then the humans finish off that final piece of the eligibility screening. So we're really enabling something that the humans can't do, but augmenting their capabilities and making them more efficient. So as I mentioned, Innovate UK have been heavily involved in the response to COVID-19. They launched one of the biggest competitions ever in April, obviously under tight time pressure. They launched a £20 million funding competition to fund innovation to support the response to COVID-19, and it was a very large competition. In 16 days, they managed to turn around 8,500 funding applications and made over 10,000 assessor matches to those applications. So this was typically in the past, these type of large competitions have taken months to close. I think 4 or 5 months would be typical for a large competition, and they were able to turn around this in 16 days using the Cobalt Grant Manager solution. So I think it really shows you the power of this kind of automated analytics capability on their unstructured data, how it has really delivered value here, managed to shrink their time to closing competitions by quite significantly from months to just a couple of weeks. So I've talked about some specific areas of text and data analytics that we've used as part of this Innovate UK solution, Cobalt Grant Manager. I just wanted to highlight a couple of others that maybe stimulate some ideas about how you might use these types of approaches to solve your own business problems. So we've looked at this idea of document similarity checking. We've looked at the analysis of unstructured data around assessors and matching those, but there are lots of other AI-based NLP techniques that can be used to deliver value in different ways. We're currently working on a food security project using a lot of these ideas for classifying news articles and also being able to search semantically for ideas within those articles that are related to food contamination, food adulteration, and issues with food supply chain. Semantic text search is a really powerful idea using AI-based techniques to search for ideas and topics rather than keywords. So things like the word fire being similar to the word blaze, or being similar again to the concept of something that's very hot. These are all things that in the semantic space are possible. With traditional keyword searches, they're not. So it gives you an additional layer of insight into your unstructured data. Additionally, classifying documents and determining what they're about is possible, in without human supervision, using these kind of AI and machine learning based NLP techniques. So thank you very much for listening. Thank you for your time. I hope that I was able to give you some ideas about how you might be able to use these kind of AI-based text analytics and NLP processes to deliver value to your own business problems.
Thank you, Alistair, and thank you everybody for sharing those insights. It would be great to take the discussion a little further with a few questions. So, what was the main driver for clients to seek out an innovative AI and data analytics solution? Let's start with Stuart from CrowdVision.
Sure. So I think for our clients, the key thing was about having actionable data available real time. So for them, the sort of underlying AI and machine learning was obviously the enabler. Actually, the real focus for them was having this high quality, highly accurate data. And Alistair mentioned it in his presentation as well, the processing time and everything being optimized so that they can actually really use this data in a live format to make a difference. And those sort of real world applications to me are why people are interested in this area of technology.
Right. Thank you. That makes a lot of sense. And in general, do we find that there's a good understanding of how AI and data analytics can be used by target customers currently, or are you all spending a lot of time on the education piece? Perhaps let's go to Alistair at Analytics Engines for that one.
Thanks, Jennifer. So yeah, as a solutions provider, we do a lot of education piece. So we do talk to our customers about the art of the possible. We understand the lay of the land in terms of how AI is progressing, what we're able to deliver in terms of the solutions around whether it's image processing or text analytics or natural language processing or maybe knowledge graph. But it's not always clear to our customers. Certainly there's an increasing awareness that there is definitely value to be unlocked from the data that businesses hold. There is value to be unlocked from automation, and there's an increasing awareness that AI and ML techniques may be able to achieve things that historically were difficult to achieve, particularly around perception of images and perception of text. So it's a mixed bag. There is an increasing awareness in business. There maybe not. We do have to do some education on exactly what's possible and what's not possible with current technology. I've also noticed this in the public sector. Looking at the tenders and things that are being released, there is an increasing move towards trying to look for data analytic solutions and AI solutions to assist with different data processing and automation within the public sector. So it's definitely something. There's a rising tide of awareness. Yeah,
Well, that's good news. Thank you. And from what we've heard today, from all of you, I'd say it's clear how much value there is in adopting solutions like these, and the understanding is obviously increasing. But so what do you think are the main challenges then, or roadblocks to more extensive adoption of AI and data analytics? Let's go to Philip for that one.
Yeah, so I think some of the challenges are really around people's understanding of them. So I think the tools themselves are still relatively in their infancy. If you'd asked me a few years ago if we'd be developing tools for customers to understand, how cyclists are moving around cities, I probably would have said no. I would have said, we'll provide these nice aggregated, anonymized data sets. We'll give that across to the local authorities who will employ their data scientists and analysts to be able to better understand it. But what we've actually found is that those folks are just too few and far between. So we've had to build a lot of those tools to allow them to be, without being unkind to our customers, they're like Google Maps. They're designed so that you don't have to have a level of technical expertise to be able to understand what the data means. And so I think one of the keys is really around the sort of abstraction of these tools out from being, technical things that have to be run by software engineers or data scientists to things that, transport planners who perhaps don't have that same skill set, but have other complementary skill sets can then make better use of that data. And I think we'll see, I think the next wave of adoption for a lot of AI and ML is in these abstracted tools that can be more generically used.
Well, that moves quite nicely on to my next question, which is then looking forwards, how do you see the future development of AI and data analytics in your sectors? Up for grabs.
Well, I think from my standpoint, I think these tools and these technologies are going to be used, more and more and more. But I think Philip's point is quite right. I think part of our expertise has to be utilizing them in a way that the output of these technologies can be, used by multiple different audiences. There's a lot of customers that we deal with that have a limited number of data analysts, and it's great getting high quality data out, but then what do you do with it and how do you apply it to your environment? So I think part of our mission is to make sure that follows the current path to make quality, accurate data very much a core of the business they're in, and making sure it's in such a way that they can actually use it and do something with it. So that would be my answer anyway.
Great.
So I think, Philip, your point was well made. There's a commoditization happening at all levels of AI solutions. We're getting things wrapped up into higher level products that are easier to consume. That's going to continue. So I think that, as Stuart said, these are the type of things that are going to drive more adoption. The higher the ease of consumption of AI tools, and quite often now we're consuming AI without realizing it. So that's also increasing. But the other thing, I think, in terms of how things are moving in our sector, I think from the technological perspective, there is a big advance that is happening in the last couple of years that is potentially sort of the next revolution. I think it's in the generative models. They're improving so fast in terms of when we're looking at text and looking at things like GPT-3 from OpenAI and the capabilities of that to answer questions about text with natural language, huge volumes of text, being able to generate text in a massively sophisticated way, like generating code without even really having been taught to generate code. So those kind of generative models, I think, are going to spark a new wave of adoption and new applications. So yeah, I see a big future for those kind of approaches.
Great. So, okay, I've put in an extra question here to wrap up. So I don't know if the audience has noticed yet, but all of your companies are based in Northern Ireland. So I'd like to just ask in sort of 30 seconds-ish, I'm not too strict on this, what is it about Northern Ireland that has helped you build a successful AI and data analytics business? And how do Northern Ireland's AI and data analytics services/solutions compete and compare on a global international stage?
Sure, I can have a go at that one. So I think there's probably two key things that really come together to make Northern Ireland companies quite special. I've lived and worked around the world, and I relocated back to Northern Ireland specifically to access Northern Ireland talent and people. I think we have, a world-class education system, some phenomenal universities, and I know in certain areas like cyber research and so on, cybersecurity research, we're just, world class. I think the other thing is the economic and support that's available is really incredibly impressive. I think we've got lots of organisations like Invest Northern Ireland and Intertrade Ireland and others who can provide not only some financial support, but also a lot of advice and a lot of connections to allow us to accelerate and do things a lot more quickly by being able to make those connections really quickly and to really achieve some phenomenal things. We have, despite not having backgrounds in the field that we're in terms of founders, my co-founder and I have we now sit on panels with companies, 100 times our size, and we're in working groups with, billion-dollar multinationals and that sort of stuff, purely because we can make those connections and we can punch above our weight.
And I have to say, Philip, I completely agree with both of those points. I mean, we founded CrowdVision in London with a handful of people. And then when we were looking to grow and expand the business and, really take the next step up, actually Belfast, Northern Ireland was just a key part of our strategy. We get great support, not only from Invest NI, but also from the universities. The way the programs run there means we get access to sort of high quality candidates in their sort of year 3 break before they go back and do the final year of their degree, and just a great talent pool. So for us, it became a bit of a no-brainer, and it's also very accessible now. So, there's services from multiple airports around the country. Even in these COVID times, there's multiple flights running to Belfast every day. And so it's just very connected to the whole of the UK. And we've, been incredibly pleased with setting up our biggest office actually in Belfast.
Fantastic.
Yes, I think we've got a fantastic pool of software engineering talent here. It's evidenced by the interest, constant interest from FDI in setting up offices here, access to those very experienced people. So I think we're very lucky here to have access to that, and we have seemingly a growing interest in the area of analytics and data science, which is also going to benefit the entire economy from growing that industry. So it's a great time to be based in Northern Ireland.
Excellent, thank you so much. So I think that's a wrap. Thank you to everybody. I really enjoyed that. Really interesting panel. Thank you all for your insights. If anybody in the audience has questions for the panelists, you feel free to contact me on jennifer.liu@investni.com, and I will pass those on. Thank you very much all.
Okay, thank you.
Thank you.
Thank you, everyone.